Welcome dear students to the online class of chemistry. Today we are going to study chapter number 7, nitric acid. Nothing is omitted in this chapter. Laboratory method. In laboratory, nitric acid is obtained by the reaction of potassium or sodium nitrate with concentrated H2SO4. You can see the apparatus on the screen. A glass retort X in which the reactants has been taken and a round bottom flask which is in the inclined position and a cooling water, a cold water tap is open on it. Reactions are potassium nitrate, which is also known as nitrate, plus sulfuric acid. It gives potassium bisulfate KHSO4 plus HNO3, and with sodium nitrate, which is also known as chili saltpeter, plus sulfuric acid, it gives sodium bisulfate with nitric acid. The temperature is less than 200 degrees Celsius. Here we have taken concentrated H2SO4 as a reactant since it is a strong non-volatile acid and it is capable of displacing the more volatile nitric acid from the salts KNO3 or NaNO3 on reaction with the mixture. Concentrated hydrochloric acid is not used since it is volatile and it will not displace the another volatile acid. The ratio of the reactants is 1:1 since sulfuric acid is dibasic acid and only an acid salt is required here in place of normal salt. Now the apparatus. All glass apparatus is used in this laboratory preparation since nitric acid is corrosive in nature. A water cooled receiver is used. You can see this, it is a water cooled receiver because cold water is running on in this round bottom flask. So to collect the condensed vapors of nitric acid, the vapors which are coming from this glass retort, they will enter in this round bottom flask, and since cold water is running on this bottom of the flask, the heated nitric acid vapors will cool down and they will convert to the liquid nitric acid. Temperature. There are two conditions. One is that we are taking the temperature less than 200 degrees Celsius and the other one is when we are taking the temperature greater than 200 degrees Celsius. So the reason behind taking the temperature less than 200 degrees Celsius is the same as it was in ammonia. Because we know that when we are heating the reactants together at the temperature less than 200 degrees Celsius, acid salt will form with the nitric acid. But if we are taking the temperature greater than 200 degrees Celsius, in that case, we are having normal salt, that is Na2SO4 or it may be K2SO4 in the case of potassium salt, and with nitric acid. Since the temperature is higher than 200 degrees Celsius, so it can damage the glass apparatus and further it can decompose the nitric acid. And the third thing is that the hard residual crust of the sodium sulfate or potassium sulfate will obtain, and it will stick to the bottom of the flask and it's a poor conductor of heat, so it cannot be removed easily from the apparatus. That's why we prefer the temperature less than 200 degrees Celsius during the preparation of nitric acid in the laboratory. Now the color of pure nitric acid and the nitric acid obtained in the laboratory. Pure nitric acid is colorless, while the nitric acid which is obtained in the laboratory, it is yellowish brown due to the decomposition of the acid. The acid decomposes to the nitric oxide, water and oxygen since it is having the volatile nature at ordinary temperatures. So the yellowish brown tinge in the acid can be removed by bubbling of air or carbon dioxide. It will drive out the reddish brown nitrogen dioxide from the warm acid and it further oxidizes into nitric acid. Dilution with water. It causes dissolution of the nitrogen dioxide gas which is soluble in water. Now the manufacture of nitric acid, which is also known as Ostwald's process. There are one inlet, a catalytic chamber. In this is the oxidation chamber where the oxidation of nitric oxide to nitrogen dioxide is held, and it is the absorption tower. Here water is running in it, and there is the outlet. Here is the acid resistant quartz is fitted here, and from this outlet we are obtaining HNO3 acid. So the first step is that from this outlet we are having the mixture, we are inserting the mixture of air and ammonia together. Here the volume of air is 10 volumes and ammonia is having 1 volume. We are taking the higher concentration of air in it because air is used in all the 3 chambers here. So we need a great amount of air in this mixture. So in the catalytic chamber, the reactants are pure dry ammonia and air, and their ratio is 1:10. Here catalyst is platinum gauge. Temperature will be here 700 to 800 degrees Celsius, which is maintained electrically in it. Nature of reaction is exothermic, a lot of amount of heat is released in it. And the products are here nitric oxide and steam. These products, nitric oxide and steam, will enter into this pipe in the oxidation chamber. In the oxidation chamber, oxidation of nitric oxide takes place and the nitric oxide converts to nitrogen dioxide here. And the last one is the third step. This is the chamber absorption tower. Here the nitrogen dioxide is converted to nitric acid by absorption of water. So here is the flow chart for the manufacture of nitric acid from the Ostwald's process. As you can see that dry air and dry NH3 are inserted through it. This is first one. A is the catalytic chamber, B is the heat exchanger, the C part is the oxidation chamber, and the third part is the absorption tower. Fourth part is the absorption tower where nitric acid is obtained. The reaction in the catalytic chamber is 4NH3 plus 5O2 in the presence of platinum and the temperature is 800 degrees Celsius. It gives nitric oxide and water and a lot of amount of heat. Since the reaction is exothermic in nature, so the electrical heating is done initially only. After the release of that much heat, it itself maintains the temperature of the reaction. So after some time we stop heating, electrical heating is stopped. In the oxidation chamber, nitric oxide and oxygen gas are reacted together at the temperature of 50 degrees Celsius and we get nitrogen dioxide in it. So the gases which are leaving the catalytic chamber, they are having the temperature around 700 to 800 degrees Celsius. So they are passed through a heat exchanger and they cool down. Through the cooling coils they passed and they cool down and now the temperature is 50 degrees Celsius. At this temperature, nitric oxide and oxygen react together and they form nitrogen dioxide. Low temperatures are used. The reason behind that we are cooling down the mixture coming from the catalytic chamber is that the easy oxidation is facilitated only at the lower temperatures and it minimizes the chances of any decomposition of nitrogen dioxide that may take place at the higher temperature. In the absorption tower is a steel tower and it is filled with quartz stone and it is having a spray of water trickling from the top, as you have seen in the diagram also. So the gases which are coming from the oxidation chamber, that is the nitrogen dioxide and the residual oxygen, they move upwards and they dissolve in the water forming nitric acid and it will collect at the base. Why quartz is used here? Since it is acid resistant. The quartz is packed in layers, so it slows down the movement of the gaseous mixture which is coming from the oxidation chamber and it initiates better solvation of nitrogen dioxide in water. Now the product nitric oxide. The nitric oxide that is obtained is dilute containing about 50% nitric oxide and it collects at the base of the absorption tower. It is concentrated by the distillation or boiling until a constant boiling mixture is obtained. Further distilling with concentrated H2SO4 under reduced pressure results in formation of fuming nitric acid. Now the physical properties. Pure acid is colorless and commercial acid, that is 68% concentrated, is yellowish brown. The odor is suffocating, taste is sour taste, and it is non-poisonous but it is highly corrosive. It is heavier than water, highly soluble in water. So since it is having corrosive nature, it affects the skin. It may burn the skin and causes painful blisters. So it combines with the protein of the skin, forming a yellow compound, which is the xanthoprotic acid, and it stains the skin yellowish color. Distillation or boiling cannot be used to concentrate nitric acid beyond a certain concentration. That means we can concentrate the acid at the boiling temperature 121 degrees Celsius up to only 68% concentration of the acid, since it is forming constant boiling mixture at this temperature. A constant boiling mixture is one which do not change its composition on boiling. So it means that on boiling, the above mixture evolves out the vapors of both acid and water in the same proportion. So dilute nitric acid cannot be concentrated beyond 68% by boiling. So further concentration of the acid is only possible by distillation of the acid under reduced pressure in the presence of concentrated sulfuric acid. This gives nitric acid of about 98% purity. And that acid is also known as fuming nitric acid. So the stability of nitric acid, as we know that it is having a volatile nature, that it means it decomposes at the ordinary temperatures or even in the presence of sunlight. So the decomposition of the nitric acid results in reddish brown nitrogen dioxide, which gives the solution a color of yellowish brown. And at high temperatures or after a prolonged period of time, the decomposition is complete and the acid turns a darker yellowish brown color. That is, the reaction is given here. You can see that HNO3 is giving Na2 plus H2O plus O2. Due to this NO2, the color is changing. So the color of the acid can be removed, as we have studied it in the previous pages, that by warming the acid to around 60 to 80 degrees Celsius or bubbling air through it. So concentrated nitric acid is always kept in plain glass bottles. So it turns yellow or yellowish brown in color. Since it is acidic in nature, so it will give the acidic results when it will react with moist litmus, methyl orange or phenolphthalein. It changes the color of blue litmus paper to red. Methyl orange changes to pink, and colorless phenolphthalein will be same as colorless. Now the ionization of nitric acid. The chemical behavior of nitric acid, it depends on its concentration. The reactions of dilute nitric acid is given here. The dilute nitric acid, when it is in the aqueous form, when it is with H2O, it gives hydronium ion and nitrate ion. You can see the reaction here. HNO3 is giving H plus ion. That H plus ion is combined with H2O, with giving hydronium ion. Since it is a monobasic acid, it behaves as a strong acid and it is giving the reactions with bases, carbonates, bicarbonates, sulfides and bisulfides, as they are shown here. That NOH, it is reacting with the alkali NOH and it is giving neutralization reaction. A salt NaNO3 is formed with water. With the carbonates and hydroxides, you can see that it is giving the respective salts with water, and with the carbonates, it is giving carbon dioxide gas as a product. Chemical properties of nitric acid. It is having strong oxidizing nature and it yields nascent oxygen. So 2HNO3 hot concentrated, it is giving H2O plus 2NO2 plus nascent oxygen. We know that the nascent oxygen is a strong oxidizing agent. So the reaction with copper with the HNO3, it gives copper nitrate, water and nitrogen dioxide. The nascent oxygen oxidizes non-metals, metals, inorganic and organic compounds. Nitric acid is having volatile nature, so it also undergoes reduction in a number of ways, like it is forming products, reduction products like NO, NO2, N2O, etc. It is depending on the acid concentration and the temperature of the reaction. Now oxidation of non-metals, carbon plus HNO3, it gives oxidized product carbon dioxide, water and nitrogen dioxide. Similar reactions are with sulfur and phosphorus also. Since sulfur is reacting with HNO3 and it is producing H2SO4, sulfuric acid, H2O and NO2. So this volatile nitric acid can be used in preparation of non-volatile sulfuric acid. Now the oxidation of metals. Magnesium plus HNO3, it is giving magnesium nitrate plus hydrogen. Hydrogen is normally not liberated when dilute HNO3 reacts with metals. And the reason is that the nitric acid on decomposition forms nascent oxygen which oxidizes the liberated hydrogen to water. So the reaction with magnesium and manganese, it is taken with the very cold dilute nitric acid at low temperatures to liberate hydrogen gas, because the oxidizing action or oxidizing property of the acid is much reduced due to dilution. So HNO3 does not normally give hydrogen on reaction with metals, but it liberates nitrogen oxide on reaction with copper, as you have seen. Dilute nitric acid liberates nitric oxide. Dilute nitric acid liberates nitric oxide. So you can see that copper is reacting with HNO3, dilute nitric acid, and it is giving copper nitrate, water and nitric oxide. Similar reactions are with zinc and iron. And when we are taking concentrated nitric acid, in this case we are having the salt of the respective metal and water and nitrogen dioxide. So you can see that copper, zinc and iron are thus oxidized by cold dilute HNO3 and hot concentrated HNO3. So these reactions prove the oxidizing nature of HNO3. Now passivity. So passivity or inertness is exhibited by certain metals under conditions in which chemical activity is expected. So iron and aluminium are rendered passive due to formation of thin oxide coating on the surface of the metal, which prevents further reaction. That means we are expecting that these two metals will react with the acid, but due to the formation of a thin oxide coating, they are not showing any active reactions. So if oxide layer is removed, mechanically or chemically, the metal becomes active again. This property is known as passivity. Now the aquaresia, the concentrated nitric acid 1 part plus concentrated hydrochloric acid 3 parts by volume, when they are mixed together, they are known as aquaresia. So nitric acid oxidizes hydrochloric acid to chlorine. You can see here, you have studied about it in the chapter of hydrogen chloride gas. HNO3 plus HCl, it gives 2H2O plus NOCl plus 2Cl. Nascent oxygen is formed here. And the noble metals like gold and platinum, they usually do not react with acids. They react with aquaresia due to the formation of nascent oxygen, and they are further converted to their chlorides, metallic chlorides. The reaction of inorganic compounds with nitric acid, they are sulfur dioxide plus water plus HNO3, it gives H2SO4 2NO. Hydrogen sulfide plus HNO3, it gives sulfur, H2O and NO. And same is the reaction with iron sulfate, acidified iron sulfate, FeSO4 plus H2SO4 plus HNO3, it gives Fe2SO4 whole thrice, H2O and NO. Now the reaction with the organic compounds. Sawdust, it reacts with nitric acid, it gives carbon dioxide, water and nitrogen dioxide. Nitration, it is of toluene. Toluene reacts with HNO3, it is the important one, and it gives TNT plus H2O. Now here we have completed our chapter nitric acid. Watch the video, and if you are having any doubts, we'll take your doubts in the doubt session. Stay safe, stay healthy, and keep studying.